Welcome to Space News from the Electric Universe, brought to you by the Thunderbolts Project at thunderbolts.info. On planet Earth, the most obvious and dramatic display of electricity in nature is lightning. But what causes lightning? Although there currently is a consensus opinion about the processes that produce lightning in clouds on Earth, most scientists freely admit that many mysteries remain. On this series, we have discussed several discoveries that add to the mysteries, including the finding that solar storms cause increased lightning on Earth, and the ongoing puzzle of lightning that occurs above thunderclouds, reaching towards space. In this episode, Thunderbolts colleague Andrew Hall explores the evidence that lightning is a product of the electromagnetic circuitry connecting the Earth and the Sun.
The following image is from NOAA and illustrates the consensus theory of lightning genesis. As you can see, it shows electrons collecting like marbles in a sink, accelerating down a slippery slope into what looks like a drain. A typical cloud-to-ground lightning needs 1 billion trillion electrons. Are electrons just randomly floating in the clouds when suddenly 1 billion trillion of them jump into an imaginary drain pipe like this image portrays? The consensus notion is that charge builds in thunderstorms because of static electricity. The friction of hailstones and rain colliding in the storm generates static charge, like rubbing a balloon against hair or shuffling feet on carpet. Positive and negative charged particles from this friction separate into layers according to the consensus notion. The layers where they are found pooling are at distinct thermal boundaries. So it's thought these thermal boundary layers keep the pools of charge apart, except when they arc. The situation is depicted in this NOAA image of a supercell, where layers of charge are shown stratified inside the cloud. To become coherent, stratified, and able to build enough charge for a 5-mile-long lightning bolt, 1 billion trillion electrons worth, the charge density required implies a plasma is involved. In fact, it's more than an implication. How else could so much charge collect to create such arcs? There's no wire in the sky, no battery terminal or electrode to generate an arc. These pools of charge must be plasmas. It only takes 1% of neutral air to be ionized for it to behave as a plasma. Lightning genesis requires a plasma because that is what forms the electrode in the sky. Let's consider lightning and how, why, and where plasma forms to play a role in making it. We know Earth's atmosphere is an electric circuit. It carries charge, current, and voltage. The air is a weak conductor with a variable vertical current between the ground and ionosphere of 1 to 3 picoamps per square meter. The resistance of the atmosphere is 200 ohms. The clear sky voltage potential averages 200 to 400,000 volts between Earth and the upper atmosphere. At any given moment, there are about 2,000 lightning storms occurring worldwide. To create lightning, the electric field potential must overcome the dielectric breakdown of air at 3 million volts per meter. It does so because the electric field in a thunderstorm jumps to over 300 million volts. A typical lightning bolt is 3 to 5 miles long and momentarily delivers about 30,000 amps to ground. The collective current from a typical storm delivers from 1/2 to 1 amp. The circuit is completed, a worldwide current from Earth to sky, and storms that return it from sky to ground. The 2,000 concurrent lightning storms, each about 1.5 amps, means this worldwide current is about 3,000 amps. Only that isn't the whole story, because there is much more science doesn't know about Earth's circuitry. There is also an exchange from atmosphere to space and space to atmosphere. This is yet to be accurately measured or understood. The existence of plasma discharges from thunderstorms to space, called sprites, gnomes, and elves for their brief and ethereal appearance, is a relatively recent scientific discovery. Their genesis, power, and frequency is far from understood. While Thornhill discusses these phenomena in much more detail in his article, The Balloon Goes Up Over Lightning, which is on his Holoscience website. Cosmic rays enter the atmosphere, adding charge continuously. The rate Earth is exposed to solar wind fluctuates widely, both because the solar current fluctuates and so does the strength of the Earth's magnetic field. Sometimes the shield it provides moves around, letting more cosmic rays enter through holes. Electricity flows around Earth in Birkeland currents molded by the geomagnetic field. How these currents fluctuate in density and the resulting induced currents in the atmosphere and ground is another area of scientific uncertainty. Because of the variability, variety, and the fact they haven't noticed until recently, consensus science can't yet understand how much current is entering or leaving Earth's atmospheric system from space. The ground also carries potential that varies. Except for the monochrome view of seismic returns, we can't even see what is below the Earth's crust to comprehend the flow of current there, nor whether, how, or where Earth's current might enter the atmosphere. For electricity, boundary layers like the Earth's crust isn't an impermeable barrier. It's an electrode. There is a cavity defined by the surface of the Earth and the inner edge of the ionosphere. It's been calculated that at any moment, the total charge residing in this cavity is 500,000 coulombs. Electromagnetic waves reflect from the boundary of the cavity, the ground and the ionosphere, and establish quasi-standing electromagnetic waves at resonant frequencies. W.O. Schumann predicted the resonant properties of the cavity in 1952, and they were first detected in 1954. They are called Schumann's resonances and are measured as broadband electromagnetic impulses at frequencies in the range of 5 to 50 hertz. The atmosphere is undeniably electric. It's not a few ions benignly floating around in the air, occasionally forming into pools of charge, but a globally active and coherent circuit. What should that tell us about lightning? Mustn't it also be part of this coherent resonant system? Doesn't it beg for a better model than marbles in a drain pipe? Fortunately, there is a model to look at. It's called electronics. Atmospheric arcs created in a circuit are generally recognized to occur by thermionic emission. Everyone has seen a hot cathode arcing, like in a welding arc, where electrons are freed from the metal surface of the electrode by heat. The metal is heated by its own resistance to current and begins emitting electrons above a certain temperature, threshold specific to the electrode material. The temperature for many materials is thousands of degrees. Another form of discharge, less well recognized, is field emission or cold cathode emissions. They do not generate electrons by thermionic emission. The electrode warms, but not appreciably because heat is not what frees the electrons. It's the electric field strength, a high voltage potential that strips electrons from whatever material is present, including the air itself. When this happens, the field forms ionic matter into a plasma structure called a corona. Corona is the electrode in the sky that discharges lightning. Coronal discharge is used in a variety of ways in modern technology. It requires a high voltage, which is precisely what is present in a thunderstorm, 300 million volts, or 1,000 times stronger than in clear weather. Corona is the only electrical phenomenon that can result in a non-thermionic discharge under atmospheric conditions. It's the driving force of the storm and the generator of lightning. Corona occurs in a layer perpendicular to the electric field where the field strips electrons from atoms, sending them downward at near the speed of light, along the field gradient to collide, inevitably, with another atom. The collision strips more electrons free to follow the electric field, leaving ions behind. The region where electrons are stripped is a cold partial plasma. Increasing charge density by stripping and collision amplifies and shapes the electric field, which self-organizes into a corona. The pools of charge layered in the atmosphere are not pools of positive and negative charges depicted, but coronas that exhibit positive or negative polarity, composed of some mixture of ions and neutral species electrically interacting. Free electrons continue the process of collision in what's called an avalanche. Avalanche is portrayed in the step-leader process depicted in the image and is a witness precursor to a lightning bolt. The avalanche is one half of the picture, however. Lightning comes from below as much as from above. The electric field also pools positive ions on the ground below the storm. Ionic streamers, filaments of positively charged air, stretch up the electric field toward the clouds. A lightning bolt occurs when the cascading step leader and streamer meet, completing a plasma channel. None of this is seen with the naked eye. It's all dark current up to this point. The lightning channel is complete when it connects to a ground streamer. The connection allows a dump of electrons from the corona to ground. Then heavier and significantly slower ions carry up the channel in a return stroke. The return stroke can be seen in the image as the bright flash that occurs the moment the first tendril of the avalanche current strikes Earth, leaving only one path glowing after the flash. Corona provides the reservoir of charge and the dark current mechanism for avalanche required to make an arc. This is what is missing in the consensus notions. The other consensus notion that static charge builds from hailstone collisions is also inadequate. A study using interferometer and Doppler radar to correlate lightning with updraft and downdraft winds showed that lightning forms in low-pressure winds around the storm cell updraft of warm, moist air. As a storm organizes and the updraft speeds up, lightning frequency dramatically intensifies. Updraft winds don't produce much lightning until they reach 10 to 20 miles an hour, the study found. Then strike frequency escalates with updraft speed. From 20 to 50 miles per hour wind speeds, lightning frequency might be 5 to 20 strikes per minute, whereas above 90 miles per hour, the flash rate can exceed 1 strike per second. It's like a motor running, and the central updraft is the primary mover. Water in a thunderstorm updraft goes through all of its phases, from water vapor to cloud condensate to rain, droplet to ice. The structure of a thunderstorm is oriented vertically around a central updraft. The phase changes stratify charge at temperatures where the transitions create ionization events. Water is self-ionizing. Water in its liquid state undergoes autoionization when two water molecules form one hydroxide anion and one hydronium cation. Water can further be ionized by impurities such as carbon dioxide to form carbonic acid. Water condensing into clouds and droplets within a strong electric field provides an ionization event. Water can become supersaturated, rising above 100% relative humidity if air is rapidly cooled, for example, by rising suddenly in an updraft. A supersaturation instability provides another opportunity for ionization. Ice is typically a positive charge carrier, meaning that current flows over its surface in streams of positive ions. Flash freezing water onto ice as hailstones grow provides another opportunity for ionization. Each layer of air in a storm has different temperature, humidity, pressure, and velocity, transporting different phases of water at different partial pressures, which means the conductivity of the air is changing too. This last item is important to remember. More about how this creates coronas requires a broader look at the circuitry of a supercell thunderstorm, which you will find interesting because it will show how coronas produce other effects. Perhaps it even explains all the effects of a thunderstorm. The electrical circuitry of a supercell will be continued in the next companion article on Earth's electrical weather. Over the series of articles we'll present, corona and its role in our weather will lead back to geology and previously presented discussions of arc blast and how mountains are built. Like all things electric, fractal forms repeat, such that a coherent picture emerges. And boy, have we got a picture for you. Thank you.
For continuous updates on space news from the electric universe, stay tuned to thunderbolts.info. Welcome to Space News from the Electric Universe, brought to you by the Thunderbolts project at thunderbolts.info. On planet Earth, the most obvious and dramatic display of electricity in nature is lightning. But what causes lightning? Although there currently is a consensus opinion about the processes that produce lightning in clouds on Earth, most scientists freely admit that
where layers of charge are shown stratified inside the cloud. To become coherent, stratified, and able to build enough charge for a 5-mile-long lightning bolt, 1 billion trillion electrons worth. The charge density required implies a plasma is involved. In fact, it's more than an implication. How else could so much charge collect to create such arcs? There's no wire in the sky, no battery terminal or electrode to generate an arc. These pools of charge must be plasmas. It only takes
many mysteries remain. On this series, we have discussed several discoveries that add to the mysteries, including the finding that solar storms cause increased lightning on Earth, and the ongoing puzzle of lightning that occurs above thunderclouds, reaching towards space. In this episode, Thunderbolts colleague Andrew Hall explores the evidence that lightning is a product of the electromagnetic circuitry connecting the Earth and the Sun.
The following image is from NOAA and illustrates the consensus theory of lightning genesis. As you can see, it shows electrons collecting like marbles in a sink, accelerating down a slippery slope into what looks like a drain. A typical cloud-to-ground lightning needs 1 billion trillion electrons. Are electrons just randomly floating in the clouds when suddenly 1 billion trillion of them jump into an imaginary drain pipe like this image portrays? The consensus notion is that charge builds in thunderstorms because of static electricity. The friction of hailstones and rain colliding in the storm generates static charge, like rubbing a balloon against hair or shuffling feet on carpet. Positive and negative charged particles from this friction separate into layers according to the consensus notion. The layers where they are found pooling are at distinct thermal boundaries. So it's thought these thermal boundary layers keep the pools of charge apart, except when they arc. The situation is depicted in this NOAA image of a supercell